This lesson is going to cover reciprocal trig function identities. Here's your starter, and here come the mark schemes. Okay, so let's just recap the reciprocal functions. Remember, the third letter will show you what it's a reciprocal of in each of the reciprocal trig functions. Okay, in AS you learnt two identities, one for tan and the Pythagorean identity. It's called that because if you draw a little right angled triangle you can prove it based on that. We're going to combine these to get some new identities. Let's focus on the tan first of all. So we've learnt about cotangent, that it's the reciprocal of tan. So if tan is sine over cos, we can take the reciprocal of that to get an identity for cot. Let's try an example based on that. In this, we're going to prove one identity is equivalent to another, so we usually pick the messiest side to start from. I would suggest that's the left. When you have lots of mixed functions, then it's a good idea to write them in terms of sine and cos. So this is a messy side. We can write them in terms of sine and cos, or we know it is reciprocal of tan, but sine and cos is easier. There we go. And we can now cancel the coses. We get 1 over sine, which you know is cosec. Here are two for you to try, and here are the solutions. Okay, again, we need to prove this, so we're going to choose our messiest side. I think the left is messier. Okay, and I'm aiming for something with tan in it. Okay, so I'm going to start on the left, and because I'm aiming for something with tan in it, I'm going to write cot in terms of tan. So now we've got a fraction in the numerator and in the denominator. So an easy way to deal with it when we have the same denominator in each of those fractions is to multiply through by the denominator over the denominator. So this is tan over tan. That just has an effect of timesing by 1, so we haven't changed anything, so our proof is still okay. And now that simplifies everything to end up with the right hand side. Here are two for you to try, and here are the solutions. Okay, this time you could argue which side is the messiest. I'm going for the left again because it's a subtraction rather than just multiplied terms. And again, we've got things that are in terms of lots of different functions, so I'm going to put them in terms of sine and cos. Okay. So sec is 1 over cos. We now have two terms, and I can't see what to do, so we're going to try combining them. If we have separate terms that are fractions, it's a good idea to combine them by adding or subtracting the fractions. So we need a common denominator of cos, and this is what we obtain. Now, as soon as we see that squared there, we can start thinking, oh, Pythagorean identity. And we know that 1 minus cos squared will be sine squared. Okay. I'm now a little bit stuck because this doesn't look like the right-hand side of the thing I'm trying to prove. So if I'm stuck, I can start working on that other side, but I'm not going to kind of join up. I need to be a bit cleverer. So tan is sine over cos. There we go. Now this looks a bit better because if I multiply the numerators I get sine squared. So what I'm now going to do is use this and work in reverse so that I get one complete proof going one direction. So we know that sine of cos is tan and we get sine. So notice your proof goes from one side to the other side. It doesn't go halfway and the other one halfway. It goes from one side to the other side. But we can use the halfway business to help us kind of cheat and reverse order. Here's one for you to try. Here's a solution. Okay, now on here it's a bit tricky to choose which side. I'm going to go with the right hand side as being the messiest one this time. Okay, so starting with the right, I need to end up with something that's got sines and coses in, so I'm going to replace my cosec and cot with some sines and coses. Okay, now again I have two separate fractions, so I'm going to add them to combine them with the same denominator. Okay, now this looks vaguely similar to the left hand side but the wrong way up. It's just a bit of a mess. Because it's super simple and there's nothing we can kind of simplify, we're going to make it more complicated. We are happy to deal with squared sines and coses because we have an identity for that. So to create some squared ones, we're going to have a difference of squares, and this kind of trick is a little bit like when you're rationalizing surds. So you need to copy the two-term bit and replace it with the same but with the opposite sign, with a minus there. If we multiply that on the top, we also need to multiply it on the bottom. And now let's expand that out. And hooray, we've got a nice squared term, so we can use our Pythagorean identity. That looks a lot better. I didn't bother expanding out the denominator before because it didn't look like it was going to make anything recognizable. And that's been quite useful because now we can cancel common factors. And we end up with the right-hand side, the left-hand side, which is super. Okay, you might have chosen to go the other way. Alright, so this is what it looks like starting from the left-hand side. So we start with the super simple sine and cos. So we look at the two terms there, and we're going to use that trick of introducing a squared by doing a difference of squares. So a bit like rationalizing surds, we're going to copy those two terms but put a plus in between instead. And what we do to the bottom, we must do to the top. Now we're going to expand the denominator and not bother with expanding the numerator because it doesn't improve matters. Okay, we can use the Pythagorean identity now that we've got a squared, and we can cancel the signs and we end up with what we had earlier. Okay, now again, this isn't looking super, but we've got kind of two terms in the numerator and one denominator. We can split that into a sum of fractions, and now this is looking more familiar. We've got cos over sine, which is our new identity cot, and you know that 1 over sine is cosec. Brill. Right, we're going to create some new identities again from the Pythagorean one. So we're going to end up with some new Pythagorean identities. So if you start with your cos squared plus sine squared is 1 and divide everything by cos squared, simplifying the first term we get 1, the second term we get tan squared, and the last one we get sec. So there's a new identity. Let's try dividing by sine squared instead. Okay, simplifying the first term is our new identity we just learned, cot squared, and then we get 1, and 1 over sine is cosec. So one way of remembering which goes with which is that you know your cos squared and sine squared, and then you've got an all the rest of the c's one, so cot squared and cosec squared, and then what's left? The tan and the sec, so they combine to make your third Pythagorean identity. So here are all of the different identities you know from year 12 and now. You can either memorize them, or if you know the two basics from year 12, you can very quickly derive the others. I tend to do that so I don't mix up which one the plus 1 goes with. I suppose plus 1 looks a bit like a T, so it goes with the one with a T in it, but you might have a better way of learning. You have to be able to know when and how to apply these, so we're going to do a few more examples. Okay, so we've got a great big mess on the left, and apparently it all turns out to be 1. It's a show that we have to show our details. Let's start by combining the fractions by adding them together with a common denominator. Okay. There we go. What a mess. Now we've got loads of different trig functions there. So we're going to write them in terms of sine and cos, just the numerator on this messy bit at the moment. Okay. If you combine sine with cosec, they will cancel out. If you combine cos with sec, they will cancel out because one's reciprocal of the other, and we just get 1. Now once we've got that simplified to be 1, we can see we've got a nice tan squared there, and as soon as we see a squared we have little alarm bells thinking Pythagorean identity, and we select the one with tan in it. So that's just going to be sec squared. And now our secs can cancel, but we still have lots of things, lots of different trig functions mixed together there. Let's write it in terms of sine and cos. Okay, on the we've got a fraction over a fraction, but on the bottom we can cancel those signs, and then these match, so that does indeed give us 1. Okay, right. On this one, we're going to start from the left, because on the right, if you expand out those brackets, you just get another difference of squares, and it doesn't look any easier than starting with the left hand side. Okay, so we've got squared terms here, so we want to use the Pythagorean identities. We need the one with sec in it, and we need the one with cosec in it. Okay. We're subtracting, so we need to be careful and use brackets, and then we can simplify that. 1 take away 1 disappears. Okay. Right, now you should recognise that this is a difference of squares. We can factorise it, and we end up with exactly what we required on the right hand side. Okay, this is a slightly different structure of question. We're given an expression for x, and we are going to substitute it in and hopefully simplify till we get 2 sec a. So just substituting straight in first of all. We have 2 terms. We could treat this as like a fraction over 1, and we want to combine them to make a common denominator of sec a plus tan a. There we go. Let's expand out that bracket, and then we'll end up with some squared terms. Okay, now once we've got some squared terms, we can use a Pythagorean identity, and we look for the one that involves tan or sec. And if you look here at the end, we've got tan squared a plus 1, so we can use one exactly as it's presented. Now we can combine the sec squared a's. Okay, and now you might notice that sec appears in everything in the every term in the numerator, so we can take that out as a common factor, which is super, because then the thing in the brackets matches the denominator and those cancel, and we end up with the right hand side. Okay, here are some questions for you to try, and here come the solutions. Here's a couple of exam questions to try. This combines what we did in the first lesson with our trig identities. Here are the mark schemes. Here's a more challenging exam question. Okay, but in a similar style to the ones you did in AS. And then here comes a solution. Well done.